We're back on live. Hello, Matt.
Hello.
So this is our third Q&A. And again, we have a bunch of questions lined up, and I will try to guide us through them. So let's start with something relatively easy. Andre asked about how advanced the content in the book is going to be, and if a beginner to intermediate developer can handle it. What do you think?
Yeah, I think it's not a book for total beginners. Well, if you've written at least a few apps or worked on a few apps, it's a lot easier to understand the problems that you get with architecture and the reasons why you would want an architecture in the first place. And some of the stuff goes pretty deep and is pretty advanced. So I think it's anywhere for intermediate to advanced. It should be very interesting.
And there's a second half to the question because he was especially interested in MVVM-C, and he asked if this chapter is already released. And no, it's not, but we plan to release this next week, or at least part of it next week. So that's where we at with this. Then we have a next question by Nathan. And he asks how many of the architectures that we present can be used in production versus how many are very experimental. Matt, do you want to take this one?
Sure. So definitely of the 6 major architectures we look at, the Elm and the MAVB are the 2 most experimental architectures. And you're not going to be able to take those and just put them in a production project and never have to worry about them. The MAVB is based on the CWL views library, which, while it works in its current state, has not been significantly deployed. And the Elm architecture that we've produced probably, I mean, to a certain extent, isn't fully implemented and has some issues. That said, if you wanted to take these code bases, they're open source. If you wanted to own them and manage all the issues within them, then they both work. We've written this app and it works, but you would need to be a bit more ambitious in wanting to control all of that and handle all of that. But certainly outside of those 2, there's at least 4 or 5 other implementations of the app that we're including that are completely ready for deployment whenever you want. And I'm including at least 1 implementation that isn't even the focus of a chapter. It's a kind of iteration on another chapter, but I guess we'll get to those sorts of iterations when we see those chapters.
Yeah. Maybe just to add to that is, if you use the Elm architecture, I wrote the implementation, and if you want to do anything that's not covered in the framework yet, which is a lot, then you would need to modify it and understand all of its internals. So in that sense, it is usable if you own it completely, just like Matt just said.
Cool. So then we have another question from Peter, and he is interested to hear about architecture pain points and grievances. So from small apps to big apps, or code bases we wrote, or code bases we've taken over. Matt, what are your biggest architecture pain points and grievances you have encountered in apps?
I mean, particularly if you're talking about adopting a code base, if you're given control and maintenance of an existing code base, the only thing that ever really ends up being difficult is when the application doesn't seem to follow its own pattern. If it's chosen to be just a straightforward model view controller, but it has huge things in the controller that are not controller layer responsibilities. It has, it's doing all of its model work in the controller, or it's got vast amounts of state in the view for some reason. outside of that, I mean, most architectures, we talk about them and go through them a little bit. So most architectures that you've heard of, they make sense, and there's a way to understand them, even if they're not your first preference. So it's not normally specific things in established architectures that cause problems. It's just when the program itself doesn't choose to follow any clear path. An application architecture should, first and foremost, communicate something to the reader of the code. And if you just can't read it, then that's really the sticking point. If you can't read it, it probably means that there isn't a clear pattern.
Yeah, so I also think that the first thing you encounter is more something you would categorize as messy code than as a particularly painful architectural pattern. And most of the difficulties stem from there and not from a wrong choice in terms of architectural patterns. And there's another question by Peter. And he asks if we are familiar with the data-oriented design espoused by Mike Acton. Chris, you had thoughts about that?
Yeah, we're not.
First of all, yeah.
So just to clarify, I looked into it a little bit to at least understand the question better. It seems very interesting. It's a way of designing your application and organizing your application around heavy data transformation. So it's used for very data-intensive applications. And we're not familiar with those, at least we're not experts on these at all, and it's not what you would normally use in most iOS apps unless you're writing games or some kind of special apps. So we're really focusing more on the sort of regular iOS apps that you see and that you use most of the time, and they're being super data efficient isn't the only priority, and often not the bottleneck.
Yes, and then there was the quote from Mike Acton, I think, and he stated understand the data to understand the problem.
Yeah, I do think that's a really nice quote. I like that a lot, and that is something you see in I think with a lot of interesting software projects. So I think Linus Torvalds also said something along those lines. And if you actually look at Git, one of the things he made, it's very interesting to see that once you understand the data structures behind it, all of Git makes a lot more sense. And I think we do a little bit of this in the view state example, where we pull out all of the view state into one place and make the data there very clear and easy to find, and not spread out all over the view controllers. And I think it helps to understand the navigation and the view state a lot better. So in that sense, there's a lot to learn there.
Yeah. Moving on to a GitHub issue by Marcus, and he noticed that there was a disconnect between the source code in the book, so in the Markdown files, and in the sample projects. And so first of all, about that, we are still working on the tooling to really keep this in sync well. So this there will be parts that are out of sync temporarily, and this will improve. But then the specific instance he noticed is actually interesting, because he noticed that at one point we were using a segue to push the next in this folder view controller we have. We use the segue to push the next folder view controller when somebody selects a cell, and then at some point we changed that to a manual approach, so just by calling push view controller. And there's actually an interesting story behind that. Matt, you were the author of this change, right?
Oh, good, blaming me. So this was related to the testing section we did in the model view controller chapter. And what I wanted to, there's a sort of prejudice that model view controller isn't testable. And I wanted to combat that somewhat by showing that you can use integration tests at a code level and run by Xcode unit tests, but integration tests on model view controller to fully test a large and complicated view. unfortunately, in doing that, there's one or two actions involving segues that you can't trigger in code. One of those is if you have a segue on a table view cell, you cannot, by interacting with the table view cell, trigger its segue action. So I started by changing the code to go through the table view delegate method did select row at index path and manually constructing the view controller and pushing it onto the navigation stack that way. And that did allow for full integration tests. You can then trigger that code and get the segue to occur, and you can verify that everything is working. And having done that, I'm going to roll back that change. It is currently in the book, yes. We're going to roll that back because it makes the code quite ugly. It takes away the ability to use segues on table view cells, which for that particular implementation, we wanted to follow Apple's suggested approach, which is to use storyboards and to use segues. So I'm going to take that out, and instead I'm just going to select the row in the unit test and manually call perform segue, which will be able to test still that the segue brings up the correct child view controller onto the navigation stack, that it correctly configures it. It just won't, the only thing it won't test is that that segue is the segue action of the table view cell. But we think that's a fair concession to make. You can pick that up through user interface tests instead. It makes the code a lot better, and you're still testing almost everything. And I might leave a little note in the testing section just to say, this is what it was, this is how it was done, and we opted not to do that.
Okay.
Did I leave anything out?
No, I think you covered it
clear.
Comprehensively. So the next question is by Tor, and I will just read parts of it to not distort what he said. So he said, when considering architecture patterns, design patterns, layers, and classes, are there any objective measures with quantitative values that could suggest the quote right abstraction level?
I don't think there are. It's very hard to pin this down and make it objective. One thing that I think is interesting is I know some programmers who love category theory and think that is the right abstraction level, and I know some other programmers who love C and think that is the abstraction level. Both they're both really good, and there's very little you could say about it. I think it all depends on the person and on the team and on the project and all these external factors. So I don't think there's anything sensible really we could answer, or anything helpful we could say.
Yeah, and I
when
noticed
looking at design pattern. Oh, sorry.
Sorry, go ahead, Matt.
We talked about this before, which is that when looking at design patterns and architectures in general, there are very few objective metrics. You can't look at code size because code size rewards the thing that is closest to the underlying framework. So it rewards MVC in this particular case and doesn't necessarily reward other architectural patterns. That's not to say that they don't have benefits. You don't want to just promote things being cryptic either. You want some verbosity, but at the same time, concision is important when you're trying to run things, but how concise do you need to be? Is 10 lines to invoke a function too much? Is one line what you need to target in all cases? You have to answer this for yourself, and you have to decide what is complex to you, and it's very subjective.
Yeah, I think the key here is really the right abstraction level for what, and in the end, the for what, I think, is the engineer working on the code and being able to maintain the code and to build features efficiently, and so it's about people and what they can do and what they prefer, and so the value judgment just comes into this very quickly, and you might be able to come up with a quantitative measure that reflects something you like, but it doesn't mean that somebody else will share your premises. So yeah, I think it's really something where we have to embrace subjectivity to a certain degree. The last question we have is from Marcus, and this is from a GitHub discussion thread, and this is about dealing with massive view controllers in a proper way. And he noticed that the first issue that we published of the objective.io magazine was on the topic of lighter view controllers. And there we presented a couple of techniques or made a couple of suggestions how you could deal with large view controllers. And then the first thing he noticed is that we actually don't employ these techniques in the MVC version of the recordings example app. So why didn't we do this?
Yeah,
Chris?
we are going to do it and release it today. So maybe already by the time you see this, it's been out. There's a bunch of refactorings that you can do to make your view controllers smaller, and large view controllers are one of the main problems of MVC, and a problem that can be fixed within MVC. So it's not necessarily a problem, it's just something that happens naturally, which you need to deal with, and which you can deal with all these techniques. So yeah, look at today's release to see more of that.
And just to clarify, we are not going to modify the base version, the example app, the MVC example app with these techniques. We wanted to keep this as standard as possible, but we are going to have a whole section in the MVC chapter that deals with all these techniques. So that's where we are going to cover it. And in the same question, he asks about basically a question about layers and where things fit in the different layers. So for example, if you would have a factored out data source object, would this still be considered part of the controller layer? Or a different example is if you would write an extension on a table view cell to which you pass a model object to configure the cell, is this actually violating some layer boundaries here, or how are you supposed to look at that? Matt, do you want to take this one?
Yeah, it gets a little bit. There's a point at which, particularly for things like pure functions that are just transforming data, they're not really part of any layer. So when you're talking about a transformation, if it's on the interface to the model, but it's only used by the controller, is it part of the model or the controller? It doesn't really matter if it's just that pure transformation. It doesn't have identity. You're not saying it lives over here. It's just, it's a transformation you apply. So there are cases where, if you have a look at Cocoa bindings on the Mac, where NS Transformer and a number of other classes were very closely associated with NS Array controller and NS Tree controller and these sorts of mediating controllers is what Apple called them. They just lived to provide a transformation between 2 points. But there was a difference between a mediating controller and a coordinating controller. Most of what we call controllers in iOS are these coordinating controllers. They're not pure transformations between 2 points. So it's a bit tricky and a bit subjective. However, one of the reasons why I like simple transformers and multiple ones all over the place is it doesn't really matter. Because they're pure functions, they can live just in utility files well outside the design pattern of the entire program. And you just kind of slot them in where you need them. So what's the answer to the question? Most of the time I consider these pure, because they act on data, I consider them more to be part of the model. And I think there are places in the book where we talk about transformations being part of the model or part of the domain logic in your program. However, you're free to think about them as different things. Certainly, if you're incorporating it with an architectural responsibility, as in I am joining the model to the view and transforming between them, then yes, absolutely, that has more of a controller feel to it because it's also acting as that bridge between two other layers.
Yeah, and I would add, especially with regard to this example of having an extension on a table view cell to configure it, that basically the idea behind it was that often if you're not dealing with a very basic, simple example project, cell configuration can become quite a bit of code, and it's nice to pull this out of the view controller. And it's easy to get hung up on the fact that it's defined in an extension on the cell, but that's basically just namespacing. So you could just write a free function, pass in the table view cell and the data, and perform the same thing. Or you could put it basically anywhere. It's not, I wouldn't consider it a layer violation just because it's an extension on this particular class, because it doesn't really matter. It's just you have to put it somewhere. And I think with regards to the layers, as long as you don't do things which really entangle them with each other, then often it's subjective and it doesn't have great consequences in many cases.
Maybe one other thing to think about is how much state does it use? So if it uses a lot of controller state, it's probably part of the controller layer, and you might design it accordingly. And if it doesn't use controller state, or if it doesn't need most of that, or if it doesn't need any state or almost no state, then it starts to matter less and less. So the more state you use, the more important it becomes to think about it, and the less state you use, the less, like Matt said, if you have a pure function with basically zero state, it doesn't really matter at all anymore. Yeah.
Okay, so that's all the questions we have for today. We'll do this again next week. So yeah, you can send questions via the GitHub discussion threads or GitHub issues, Twitter, email.
Fax. Yeah, we'll take anything.
Yes.
Cool.
Cool.
See you next week, Matt.
So thanks, Matt.
Okay, bye. Don't fax me.
Thank you, everybody. Bye-bye.
Bye.